Hello everyone. Today we're looking at reactions of alkynes with hydrogen. And that process is called hydrogenation. And this is presented by science visualized. Alkynes contain carbon-carbon triple bond. So for example, this has a CH triple bond, that one, and then carbon connected to a CH3. So that carbon number 3 is a CH3. Alkynes can be hydrogenated. That means they can be reacted with hydrogen. You end up adding hydrogen and hydrogen across the triple bond. So you end up adding hydrogen there, and then twice, so 2 times. And basically you end up adding hydrogen, hydrogen, and then again hydrogen, hydrogen, and it reduces it all the way to alkane. So that reaction requires hydrogen gas and a metal catalyst, which could be palladium or nickel or platinum. So anytime you see hydrogen with palladium, sometimes they have palladium deposited on carbon, or hydrogen with nickel, hydrogen with platinum, any of those will catalyze hydrogenation of triple bonds all the way to alkanes. The second type of hydrogenation is called cis-hydrogenation. Cis means you're adding hydrogen and hydrogen from the same side, so same side, and that's called cis addition. And as a result, you end up with what's called a cis-alkene. Cis-alkene has the 2 alkyl groups on the same side of the double bond, so that and that, same side. So for cis-hydrogenation, you use hydrogen like what we saw before with palladium or nickel or platinum, just like what we saw. But now you add Lindlar's or Lindlar catalyst, which could be calcium carbonate, so that will be hydrogen, palladium, and calcium carbonate. But you could also have other types of metal salts. Most commonly used are transition metal salts. So anytime you see hydrogen with any of these metal catalysts with a salt, then that's going to be cis-hydrogenation. So that means the product is going to be a cis-alkene with hydrogens added on the same side. The last type of hydrogenation is called anti-hydrogenation. The reason it's called anti is because you add hydrogen and hydrogen from opposite sides, and the result is a trans-alkene. So you end up with an alkene where the alkyl groups are on opposite sides of the double bond. For this reaction, you need any of the group 1 metals, sodium or lithium or potassium, with ammonia. And the other name for this reaction is dissolving metal reaction. It's actually a free radical reaction. So anytime you see sodium with ammonia or any of the other group 1 metals, that's going to be anti-addition of H and H to give you a trans product. If you enjoyed this presentation, please consider supporting the channel by subscribing and also by liking the video. Thank you.